Have you ever wondered what actually happens behind the scenes when you ping a device on your network? To see that raw data, we are going to use Wireshark. It acts as a packet analysis tool, capturing those invisible frames so we can crack them open. To follow along, you will need three things: a Windows PC, an active internet connection, and Wireshark installed on your system. By the end of this video, you will move past textbook theory. We are going to capture live network traffic and visually prove exactly how your computer talks to the internet. Let's establish our local network baseline. Step 1. Open your Windows command prompt. Type the command ipconfig and press enter. This pulls up your system's current IP configuration. We need to locate two specific lines in this text. Find the IPv4 address and right below it the default gateway. Write both of these numbers down. That default gateway is your local router. It is the single doorway through which all of your local data must pass to reach the outside world. Launch Wireshark. On the Start screen, you need to select your active network interface card. You can identify the correct one by looking for the fluctuating traffic line next to the interface name. Double-click it to start capturing. Right now, Wireshark is capturing all traffic on the interface in a rapid, continuous stream of raw data. To isolate our ping packets, click the display filter bar at the top and type ICMP. Use lowercase letters for this filter. The box will turn green when the syntax is correct. Press enter to apply it. This filter does not block Wireshark from capturing other data. It simply hides the background noise so we can focus on this specific conversation. Return to your command prompt and ping the default gateway IP address you wrote down earlier. Once the replies finish, switch back to Wireshark and click the red Stop Capture button. Your packet list pane should now be populated with echo request and echo reply packets. This is the raw data exchanged between your PC and the router. Click on the first echo request packet in the top pane. Then, in the middle details pane, expand the section labeled Ethernet 2. This header contains the hardware addresses. You can see the source MAC address belonging to your PC and the destination MAC for your router. A MAC address acts like a house address, used exclusively for physical, local delivery on your immediate network. Check the frame type field. The hexadecimal value 0x0800 confirms that this specific Ethernet frame is carrying IPv4 data. This packet is now fully addressed and perfectly prepared for a direct neighbor-to-neighbor jump across your local network segment. To see how addressing changes for the outside world, click the blue Start Capture icon to begin a new session. Select Continue without saving. In your command prompt, ping an external website like Cisco.com. After the replies finish, stop the Wireshark capture. Select the new remote echo request packet and expand the Ethernet 2 details just as we did before. Compare captures. The remote destination IP is a public address, different from our local test. Yet the destination MAC address is exactly identical. The IP acts as a GPS location for the final destination, while the MAC remains the immediate doorway. This demonstrates a core rule. Your computer always addresses local Ethernet frames to the gateway's MAC address, regardless of where the data is ultimately going. You have now successfully extracted, filtered, and analyzed all the live Ethernet frames moving across your local network. This lab confirms that MAC addresses handle the local handoff, while IP addresses manage the journey from one end of the connection to the other. For a new challenge, clear your ICMP filter and look for ARP traffic. This will show you exactly how your computer learned the router's MAC address before the first ping was even sent. Seeing these headers in action provides a practical foundation for understanding how data actually moves through a network.